Seated on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be exploring some of the basic built-in operators in Python, as well as some of the more advanced mathematical functions found in the Math module. Let's get started with basic operators. Operators are used to perform operations on objects and values. These operations can be as simple as adding two numbers together, or as complex as checking if a value is in a list of values. Operators are represented by either a special symbol, such as a plus sign for addition, or a keyword such as the in keyword to check if a value is in a collection. There are many different types of operators, and they fall into several categories. In this video, we're going to be taking a look at assignment and arithmetic operators. Later in the course, we'll investigate many of the other categories of operators as they come up. The first operator we'll take a look at is the assignment operator. And in Python, it looks like an equal sign. But don't get it confused with the equal sign you might be used to from your math classes. Assignment is a bit different. It's not stating that the values are equal or comparing the values. Rather, it's used to assign the value on the right hand of the statement to the variable on the left side. This causes Python to create a new object in its memory and then bind the variable name to that object so we can easily look up the value when we need it. Let's now take a look at a few examples. The first example here is assigning the integer value 3 to the variable x. This causes Python to create a new integer object with the value of 3 in its memory that we could refer to later by the variable name x. Keep in mind that this is not arithmetic. So if we had another line, such as x equals 4, this would not mean that 3 equals 4, or return false or something like that. Rather, it simply means that the variable x is now pointing to the value 4 and not 3. The old value of 3 would now be lost, and for future lines of code, x would equal 4 and not 3. Here we see another example. In this case, a string, that is, a text value, is assigned to the variable y. Assignment is not just limited to integer values, it works for all data types. As another example here is a floating point number. That's a real number with decimal points, and in this case it's being assigned to the variable z. And we're not limited to only having literal values on the right-hand side. We can also have expressions like this one. When we have an expression on the right-hand side, the expression is evaluated, and then the result of that expression is assigned to the variable on the left side. In this case, the value of 30 would be stored in the variable a. The expression can also involve other variables and functions. Just like in that last example, the expression on the right is evaluated, and the result is assigned to the variable. In this case, if x was 3 and y was 1.23, the value stored in b would be 4.23, which is the result of adding 3 and 1.23. So keep in mind, the expression on the right is always evaluated, and then the result is stored in the variable on the left. Let's now take a look at a more complex example and try it out in the Python console. Okay, on the screen right now, we can see the Python console that I'm using through PyCharm. On the left-hand side is the console, that's that sort of black area with the flickering cursor. On the right-hand side, it's going to keep track of any variables that we've created. So let's get started by replicating that example that we saw in the slides. And the first line was x equals 10. So we've now assigned the value of 10 equal to x, and on the right-hand side, you can see that it's keeping track of it for us. And since we're in the Python console, we can just type x, and it will tell you the value of that. However, in a real program, you would need to use the print command to get the output returned to the console, like that. So the next line of the program was y equal to 5. And now you can see we have a new variable declared, and it's an integer, and it's equal to 5. Both 10 and 5 are integers, and Python recognizes that. Our next line gets a little bit more complicated, where we're saying z equals x plus y. So what happens in this case is Python is going to look up the value that x is bound to and the value y is bound to, and it's going to turn those values and then complete this arithmetic. So it's going to add the value of x to the value of y, and then the result of that is going to be stored in z. So we can see we have z equals 15 pop up, And if we typed in z into our console, we could see the value is 15. Now let's try the next line, x equals 3. So it's important to note here that this is changing the value that x is bound to. It doesn't have any retroactive effect on x plus y, in that z equals x plus y. You can see that z, if we typed it into the console here, is still equal to 15. The only thing that's changed is x equals to 3, because the assignment operator isn't arithmetic. It doesn't mean these are true statements forever. It just means take whatever's on the right and store it in the left. So same thing if we update the value of y, let's say to 2. And we can see y has been updated, but z still remains as 15 because that was the last thing xz was bound to. Y is now equal to 3, or 2 rather, and x still remains equal to 3. And we can also sort of update the value of these variables. Really, we're just creating a new value and bounding it to it. But let's say we wanted to add 1, or any number, to z. We could do it like this, z equals z plus 1. This would mean that we're going to look up in the memory what the value of z is, add 1 to it, and then store that back in z. So you can see that z has now updated to 16, and when we try putting up the value, we can see it is indeed 16. And we could do that for any amount. For example, we could subtract from z. If we want to subtract 10 from z, z's now 6, and then we could add 10 back. And we have 16. And that last line in the program we were looking at was a print line, and it was simply print x, y, z. And in print, when we give a comma and then a list of values to print out, it puts a little bit of a space between them by default. So we can see we get the values 3, 2, and 16 all on the same line. The 3 would be for x, the 2 would be for y, and the 16 would be for z. So the big takeaway here is to think of this as assignment and not arithmetic. Let's go back to the slides. So as we saw in this example, the output would be 3, 2, 16. 3 would be for x, 2 would be for y, and 16 would be for z. Moving on now to arithmetic operators. And we've already seen a few of these in that last example, such as the plus and minus operators. And these allow you to perform arithmetic on numerical values such as integers and floats. And we're going to take a look first at the most common arithmetic operators, and you're probably already pretty familiar with these. These are things like addition, subtraction, multiplication, and division. And they'd work pretty much as you'd expect, but we'll still take a look. Here, in this example, the addition operator is being used to add 5 and 10, and of course, that would result in a 15. Subtraction, we have 10 minus 5, and that's going to result in a 5. Multiplication, 5 times 10, that's going to equal 50. And division, 10 divided by 4, is going to be 2.5. So one other thing we should consider is the types that these are going to return. So when we're doing addition or subtraction on two integer values, we get an integer value in return. If one of those is a floating point value, we're going to get a floating point value in return. If we're doing division, like we see on the screen, we're going to get a floating point value. And with multiplication, again, it matters whether they're both integers or an integer and a float or a float and a float. If there's some float in there, you're going to get a floating point value. And again, you can always test that with the type function. Here are a few more arithmetic operators, but they might be a little bit more complicated, and some of these you might not have seen before, at least in programming. Integer division, which is the first listed here, is just like that division operator that we just saw, except it results in an integer. That is a whole number, regardless of what terms are being used. So any decimal places at all are simply cut off. In this example, 10 divided by 4 would normally be 2.5, but with integer division, the result is simply just 2 because we truncate those decimal places. The exponentiation operator finds the value of the left value raised to the power of the right value. So if it was a asterisk asterisk b, it would be a raised to the power of b. Or in this example here, it would be 2 to the power of 10, which is 1024. Negation is equivalent to switching the sign of a value or simply multiplying it by -1. Unlike the other operators we've seen so far, negation is a unary operator, meaning that it only involves one value. All the ones we've seen so far would be binary operators that involve two values. In this first example, we are negating the value of 5, which results in -5. The second example is a bit more complicated. this would be minus minus 4, or negating the value of 4 twice, which simply results in the value of 4 again. It would be like timesing 4 by minus 1, then timesing it by minus 1 again. The last arithmetic operator we'll be taking a look at is modulo, and you can think of this as remainder. That's also referred to as mod. Modulo finds the remainder of dividing the left value by the right value. So we divide what's on the left side by the right side, and what's returned isn't the result of that division, but the remainder. Let's take a look at some examples. In this first example, 10 is divided evenly by 2, and there's no remainder, so the result is 0. In the second example, 10 is divided by 3, and the result is 3, with a remainder of 1. So what's returned is the remainder, which is 1. In the next example, 5 is divided by 6, and the result of this would be 0 with some remainder. And in this case, that remainder would just be 5. So the return is 5. In the last example, 5 is divided by 3, which would be a result of 1 and some remainder, and that remainder is 2. So the result is 2. So you can really think of this operation as the remainder operation. And this modulo operator can be more useful than you might think. We're going to see it coming back in quite a few examples in this course. Just like when we're doing arithmetic in math class, there is a set order of operations that we have to follow. The order of operations in Python is similar to that of real mathematical operations, although things can get a bit more complicated when we throw in non-arithmetic operators into the mix. So a simplified version of this is given here. Parentheses have the highest order of operations, meaning that they're always evaluated first, then exponents, then multiplication, division, and modulos, and then lastly at the lowest level, addition and subtraction. As an example, let's say we want to implement this equation in Python. We could use a combination of parentheses and arithmetic operations to create equivalent formula in Python, as long as we follow these orders of operations carefully, just like we would in writing a math formula on a single line. The key here is using parentheses whenever we want to alter the order of operations, just like we would in mathematical equations. One last thing I should mention about assignment operators is that there are shorthand versions of many of the assignment operators that we would frequently be using, and these are called compound operators. These all involve performing an arithmetic operation on a value stored in a variable, and then storing that result back in the same variable, sort of like adding 1 to z, like we saw before. For example here, the plus equals operator, such as x plus equals 5, is equivalent to adding 5 to the current value of x and then storing that value back in x. Let's take a look at a more detailed example, because I know that might sound a bit complicated. The example we see on the screen right now uses some of those compound operators that we just saw to change the value of x. This acts as a sort of shorthand for a longer assignment operator. The first line here simply assigns the value of 10 to x. Then it outputs that value to the console, which is going to be 10, of course, because we just set it to 10. Fairly straightforward so far. Now we've arrived at our first compound operator, and this is x plus equals 5. And what you can think of this as doing is simply adding 5 to the value of x. In reality, under the hood, what it does is it retrieves the value of x, which is 10. It adds the result of the expression on the right-hand side, which is simply just 5 in this case, and it creates a new object with the value of 15, and then x is rebound to it. At least that's what's going on under the hood. Again, you can think of it as adding 5 to the value of x. So in this case, it causes it to update to 15, because 10 plus 5 is 15. The next line here prints out that value, and that current value of x after this line would be 15. Note that this doesn't retroactively change any lines we've already output. Once those lines are output, there's no going back. The last compound operator in this program is a bit more complicated. In this case, we have the subtraction assignment operator, but we also have a more complex expression on the right-hand side. In this case, the expression on the right-hand side is first evaluated to get 7, 10 minus 3 is 7, and then the value is subtracted from the current value of x. This equation is equivalent to saying assign the value to x of x minus 7, or simply subtract 7 from x. In this case, x currently has the value of 15, so 15 minus 7 is 8, and the value of 8 is now assigned to x. So when we get to that last line of the program, which is simply a print statement that prints the value of x, we get the current value of x, which is 8. So the last line of output we get from the program is 8. So the overall output of this program would be 10, 15, and then 8. The arithmetic and assignment operators we've seen so far are fairly powerful, and we can do a lot with them. But often there are complex mathematical operations we'd like to do, and it would be a pain if we had to build those up from the ground using only basic arithmetic. Lucky for us, Python provides us a library of mathematical functions already made for us to make our lives easier, and provide some of those math functions that might not be possible or would just be too troublesome to code ourselves. Here's a list of some of the built-in math functions that should always be available. So for these, you don't have to import anything or do anything special. You can just use these functions right out of the box. The ABS, or absolute function, finds the absolute value of a number. The round function allows us to round a number using conventional rounding rules. That is, 0.5 and up is going to be rounded up, and anything under 0.5 rounds down. The max and min functions do what you'd expect, and they return the largest or smallest values in a list of values passed to the function. There's a few examples listed here on the screen. You can go through them. I won't go into too much detail because they are fairly straightforward. But what if we need more advanced mathematical functions? Well, to get access to those more advanced mathematical functions, we need to import them from a module. Python modules are files containing Python code such as functions, classes, constants, and variables that we can import into our programs. This is a great way to reuse code or take advantage of code that's already been created for us. The Python standard library comes with many pre-built modules, such as the math module, that contain helpful functions we can use in our own programs. But before we can use these functions from these modules, we need to import them into our programs using the from and import keywords. Let's look at an example of importing the square root function from the math module. Here, math is the module we're importing from, and square root, or sqrt, is the function we're importing into our own program. After we import the function, we can use them in lines that come after it in our program, but they have to be after the import line. In this example, we then use the square root function to find the square root of 9 and store the result in the variable x. In this case, the result would simply be 3, the floating point value, 3. The math module contains many other useful math-related functions, in addition to square root. I'm not going to go too in-depth into all of these because there are a lot of them, and they're mostly what you would expect, and you can read about them in the documentation of the math module. But some common functions include the for and ceiling functions, the log function, and the natural exponential function. The module also contains functions related to trigonometry, such as cos, sin, and tan, mathematical constants, such as Euler's number, pi, and tau, and there are many more functions in the module. So I highly suggest that you check out the documentation for the math module, and you can find that at the URL and explore all of the possible options that are available to you. Okay, now that we know about the math module and how to import functions from it, let's try putting it to use. And here we have a little bit more complex example than what we've seen so far. This example program inputs two 2D points from the user and calculates the distance between these points. You may recall from high school math that the formula for distance between 2 points is the square root between the sum of the horizontal and vertical distances between these points. This equation is represented in our Python program on this line here, which uses the square root function from the math module, as well as some basic arithmetic operators that we've covered so far to find the distance. The other important line here is our import line at the top of the file. It's important that we import any functions we need that are not already built into Python before we use them. In this case, we are importing the square root function from the math library, as we need this for our distance calculation. The remaining lines are simply getting input from the user and outputting the result. One important thing to note here is our use of the float function to convert the string input by the user into a floating point value. If we forgot to do this, we would get an error about incompatible types when we try to perform arithmetic on a string value. So when you want a number from a user, maybe an integer or a float, and you're using that input function, remember that you have to cast its correct value before you can do arithmetic. So let's try running this program and see how it works. Okay, here we are in PyCharm. Let's run this program and see what happens. So here we have our console down here. I'll move it a little bit bigger. And we can see it saying this program finds the distance between points x1 and y1 and x2 and y2. This line of output's being caused by this print line here. Then goes to the next line, x1 equals the float of whatever we input for the value of x1. You can see input the value of x1 is being output as the prompt to the user, and the program has stopped and paused and it's waiting for our input. So I'll put the value of 4 in, and now we get to the next line, which would be y1 here, and it's asking for the value of y1. In this case, we'll input the value of 8. So our first point is going to be 4, 8. Now we're going down to the next line, and we are asking for the value of x2. We'll put in a 12. And now we're going down to here, y2, and we're going to input that value. In this case, I'll make it 14. Now, as soon as I hit enter, it's going to get a value of 14. It's going to do this calculation here using the values we'd entered. We already converted them to floating type. And then it's going to output the distance here. Note that we didn't have to convert dist here back to a string because we're not trying to add it to this string. We're just using a comma. So these are two different values being sent to the print function. The first is the distance is, and then the second is dist. When we give a list of values like this, by default, print just outputs them on the same line with a space between them. So when I hit enter here, it should give us the distance. In this case, it does, which is 10, and that is the correct value. So if you're confused at all about this, you might want to try breaking it down using those lists of order of operations that we saw before. The first would be calculating these values in the parentheses, x2 minus x1, y2 minus y1. Then we'd use the exponents, so that whatever this value is to the power of 2, whatever this value is to the power of 2. Then we add those two values together, and then we finally take the square root of those values and store the value in dist. Then dist is outputted at the end here. So hopefully that made sense. Let's switch back to the slides. Okay, we are back to the slides, and this is the output we got when we tested out that program. And these examples are available to you on our learning management system, so if you'd like to try it out yourselves, try downloading it and running it. One last thing I should mention in this video is that there are a few other ways to import functions and variables from modules. We've already seen how you can import a single function from a module. That's shown up here right now, and that's the from keyword, the name of the module, import, and then the function name, which is the name of the module trying to import. However, there are some other methods. And what we see on screen right now is an example of importing multiple functions in one line. In this case, instead of just listing the function, we list a list of functions separated by a comma. In this example, the cos, sine, and tan functions would all be imported from the module math. We can also import all functions in a module at once by using an asterisk rather than a list of function names. This example would import everything in the math module into our program. One reason we might not want to do this is that it would bind variable identifier names for all of the functions and variables in the math module, and this could conflict with our own names. For example, this would bind the name e to the constant for Euler's number, and that could interfere with e in our program if we already defined it. The last method we could use is simply stating import math at the top of our file. This imports all functions and variable names from math, just like in the last example, but the difference here is it prefixes the names with the module's name to avoid any conflicts. So note that if you use this method to import the math module, you would need to prefix each function call with the name of math, as is shown here. For most of the programs we'll be working on in this course, you can use any of these methods. So it's mostly a personal preference, but you should try to maintain consistent style and keep name conflicts to a minimum if you're going to import everything from a module. That's all I have for you on Python operations and arithmetic. I highly recommend checking out the math module as it may have some important functions that you will find useful when creating your own Python programs. Thank you for watching and have a great day.